Today we are going to discuss how to find out the angle of prism by using a spectrometer. So let us first of all see what is meant by an angle of minimum deviation. When a ray of light is incident on one of the refracting faces of a prism, emerges out from other refracting faces in different direction. Means what? Here, when a ray of light is incident on a prism, there will be a turn of a light takes place. The angle of the light ray turns due to refraction through the prism is called the angle of deviation. There are different angle of deviations for a different angle of emergence of the incident ray. For a certain angle of incident ray, the angle of deviation is minimum, is called as the angle of minimum deviation. At this angle of minimum deviation, the angle of incidence and the emergent ray are equal. If we know the angle of prism and delta m be the angle of minimum deviation and mu be the refracting index of a prism is given by formula mu is equal to sine a plus delta m upon 2 divided by sine a by 2. So how to determine the angle of prism by using a spectrometer? So this is the spectrometer. First portion of the spectrometer is a collimator through which an incident light is falls on a prism. Middle part of the spectrometer is a prism table, or we can call it as a prism base. And last one, through which we can observe the spectrum, is called as a telescope. So this experiment is carried out into three parts: focusing, leveling, and last one is measuring, or how to take the reading. So we will see one by one in this video. So in the focusing part, let us focus. Let us turn the telescope on the illuminated background like a wall. So you can use anything. Looking into the eyepiece, keeping both the eyes are open. By adjusting the eyepiece in and out until you see cross wires are distinctly separate. Keep a lens of a minimum focal length. So you can choose any convex lens of a focal length. But here one condition is that focal length of that convex lens should be small. Keep index pin in the focus of a lens and telescope of the spectrometer on the other side of the lens. By adjusting the length of the tube of this telescope by using a rack and pinion arrangement, there is no parallax between the cross wire of a telescope and a index pin. So do not disturb this tube length hereafter. This telescope is ready for the observation. Now we illuminate the slit by using a given source. Bring this telescope in line of a collimator. adjust the length of this collimator by using a rack and pinion arrangement until you see there is no parallax between the cross wire and slit of a collimator. If we remove this parallax, then this spectrometer is ready for obtaining a parallel beam of light. So do not disturb the position of this or the length of the tube length of this collimator hereafter. This is the focusing of a spectrometer. Then how we can level the spectrometer? So keeping a spirit level on a telescope by adjusting the screws of this telescope until the bubble stand at the center of the telescope. That bubble stands center in this leveling bottle. Once it is adjusted, then now keep this leveling bottle on a collimator by adjusting the screws of a collimator until the bubble stands at the center of the leveling bottle. Now adjust the proper height of the prism table. Keep a leveling bottle at the center of this prism table. By adjusting the screws of this prism table, bubble stands at the center of the leveling bottle. So at every position you can see the bubble stands at the center of the leveling bottle. After that, we will move towards the reading of this spectrometer. How we can take the reading? Keep the prism at the center of the prism table, whose angle of prism is towards the collimator, and base of this prism is perpendicular to the incident ray of light. When a monochromatic light, means a parallel beam of light, falls on both the refracting faces AB and AC of a prism. Okay, now you rotate or turn the telescope on one side of the refracting faces, that is AB, until you see the reflecting beam of incident ray when it is matches or coincide with the vertical wire. Fix the telescope. Note down the two readings. Keep the prism at the center of the prism base so that parallel light from a collimator falls on a two refracting faces AB and AC of a prism, and base towards the telescope. That base of the prism is perpendicular to the incident ray of light. So clamp the prism by using a clamping screws below the prism table. if this clamping of the prism takes place, then turn the telescope until you see the image of the refracting ray of light from the face AB until it match to the cross wire. Fix the position of this telescope T1. Note down the readings on these two windows X and Y. Now turn the telescope to get the image of the reflecting ray of light from the second refracting face of a prism AC until the image of this reflecting light matches with the center of the cross wire. Fix the position of that telescope. It is T2. Note down the readings on the two windows X and Y. So you difference between these two readings of T1 and T2, we get the angle of prism, that is a 2A, and take the average of this 2A divided by 2, you can get the angle of prism. Exact value of the angle of prism is 60 degree. And how we can take the readings we'll see in this video. In a spectrometer, there is a circular reading. Okay, it starts from 0 degree and 90 degree, 180 degree, 270 degree, and it is a 360 degree. So it is a circular type of reading seen on a spectrometer. So in a spectrometer, there are two types of scale. One is a main scale and another one is a vernier scale. So in a main scale, there is the smallest division on a main scale is a 0.5 degree. Okay, and if we consider there are the two types of spectrometer are available in the market, in which there are 1 degree smallest division on a main scale is a 0.5 degree or a 1 degree. So 1 degree is equal to 16 minutes, and if it is the smallest division on a main scale is a 0.5 degree, then it is considered as a 0.5 degree is equal to 30 minutes. So vernier scale, so there are the vernier scale on a spectrometers. If there are 30 lines or maybe a 60 lines, but in our laboratory we are using a smallest division of a spectrometer who is 0.5 degree and 30 lines are on a vernier scale. So that vernier scale and main scale are seen on the spectrometer are look like this one. This is a 0 and 30 lines of a vernier scale seen on a spectrometer. In our reading, if it is seen that 0 line of this vernier scale just cross this 160 degree and 170 degree is seen on a left hand side, then how we take the readings or write the readings for this telescopes spectrometers position is T1. So see that where is the 0 line of this vernier scale crosses. So in this our reading, it is seen that this 0 line of a vernier scale crosses the 160 degree. So I write the main scale reading of this spectrometer is 160 degree, and I will see here where is the line of a vernier scale matches with the lines of a main scale. In our reading, it matches the 18 number of lines of a vernier scale match with the or coincide with the line of a main scale of a spectrometer. So therefore I can write here our reading is 160 degree 18 minutes. Okay, if suppose that this zero line of a vernier scale cross this 0.5 degree, now suppose it is here, so our reading in this situation is, our main scale reading is, where is your zero line? It crosses the 0.5 degree, 160 degree, 0.5 degree, and near to be, it doesn't cross the 1 degree, means it is a 161 degree. So it is above, in front of this 161 degree and crosses to this 160 degree 0.5 minute. So here in this situation I can write the reading as 160 degree, and 0.5 degree means it is a 30 seconds. If the 15 number of or a 12 number of lines of a vernier scale matches with the lines of main lines of a spectrometer, then I can add this 12 number of lines into these 30 minutes. So our reading becomes as a 160 degree 30 minutes plus 12 minutes, it is a 42 minutes. So our, in this situation, second situation, our reading becomes as a 160 degree 42 minutes.